Hey everyone, welcome back to my YouTube channel. You are watching Build AI with Sandeep. In my previous videos, we have learned what is transformer architecture, and now it is time to move toward large language models or LLMs. So, in today's video, I'm going to tell you the story behind large language models from 2017 to 2023. So, let's quickly start our today's video. In 2017, Google introduced a research paper that named is Attention is All You Need. And in this research paper, transformer architecture was firstly introduced. So let's first understand why this transformer architecture was so important at that time and also in today's world also. So previously we have NLP models like RNN and LSTM. RNN and LSTM. So we used these two models to train our NLP model. So there was a big limitation in these two models that we can we can train these models by giving word by word. We can do sequential training using these two models. There was no parallel processing. We could not pass whole sentence into these two models. So that problem solved this transformer architecture. And how did this architecture solve that problem? Because it have attention mechanism. Attention mechanism help the transformer model to look at every other word, and we can pass one sentence, each word of one sentence or multiple sentences to this transformer architecture, and all can be done parallel processing using parallel processing. So this was very beautiful research. Basically, this can be considered very beautiful because we can scale this transformer architecture. Previously, RNN and LSTM was not scaled due to the sequential learning, and this can be done using self-attention. It have self-attention. I already explained the self-attention mechanism in my previous video. If you have not watched, then please do watch this video first, so that you can understand how parallel processing is happening inside the transformer architecture. So yes, and now if I can tell you its main goal in the research paper, its main goal was machine translation. Machine translation. It means that we can pass an input sentence in one language to our transformer architecture, and our model will generate the output sentence in another language. So as you can see in this diagram, that we are giving input in French and we are getting output in English. So transformer was task specific. It We cannot use the transformer architecture for general purpose. For example, if we can we can give prompt that please return this Python code, or we can ask please summarize this test, or it 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 was not usable for question answering also. So that is why this was the big problem at that time. That So then after, researcher asked a simple but deep question, that instead of teaching our model various tasks separately, why don't we train our model on simple but general task? And that task was language modeling. Language modeling. And you all know what is language modeling. It means we can train our model so that our model predict next token given the information of previous tokens. And this can be done using decoder mass self-attention. Okay. So this idea led to GPT-1. Now in 2018, OpenAI came up with GPT-1 model. So GPT, let me tell you about the architecture point of view of GPT-1, that GPT uses only decoder of this transformer architecture, and everything was same inside the decoder that is in transformer architecture. Everything was similar, but there was one difference, that in original transformer there was six decoder layer. As you can count, there are six decoder layer, but GPT-1 OpenAI team used 12 decoder layers, 12 layers of decoder to train the model, and they used 117 million parameters. What are these parameters? These parameters are nothing but weights and bias that learn during backpropagation, during training. Okay, so this is all about the architecture in GPT-1. Nothing different used, same decoder architecture. They removed the encoder. Why did they remove encoder? Because see, in machine translation, we have two sentences. One is in French language and one is in English language. Okay, so we have two input sentence and our model predicts something. Our model predicts something and we compare the original English sentence with the prediction. Then we compute loss. So here we have two different input sentences. But to predict next token, we only have one sentence. And we all know that encoder main job is to read and understand the input sentence. And the decoder job is to generate the new output, generate new token, new next token, next word. So that is why OpenAI team use only decoder only, and they mainly focus on generation. They mainly focus on generation, generating new words basically. So, so next thing is I want to tell you that let's understand about training. How was training happened for the GPT-1? So training was done in two stages. The first stage is generative pre-training. Pre-training. The second stage is fine-tune on various tasks. So in first phase, generative pre-training, what OpenAI team did, that they took data from 7,000 books. They take raw text only from the 7,000 books and train that model, and the objective was next word prediction. That's it. Nothing changed. And they used 12 decoder layer, and this is the generative pre-training. And in generative pre-training, the main goal was to make our model understand the language more better, so that our model can understand the hidden patterns, the patterns inside the language. So that's why so you can understand generative pre-training like that, that first our model was reader. First our model was reader, and then after it will act like a student who understand the language. And in fine tune on various tasks, then after the same pre-trained model could be used on various tasks. What are the various tasks? Various tasks could be text summarization, or we can say question answering, or we can say machine translation also. So the idea was simple, that uh, that using generative pre-training, we can make our model understand the language better, and then after we can use the model on various tasks to solve various tasks. So basically, as a result of GPT-1, people researchers show that the pre-trained model we can use pre-trained model on various tasks. It solve mostly NLP use case problems. Then in okay, in the same year, Google also gave a model. Google also introduced their language model, and that name called BERT. In the same late 2018, and let me tell you something about architecture. So this BERT model was encoder based. They use same 12 layers of encoder, and and in this model there are 110 million parameters, and this model BERT was really good in understanding the input. But this model, but it is bad in generating. So yes, now this model, due to the BERT model was encoder based, it is really good in understanding the input sentence. It can get the complex pattern. It can capture the complex pattern in the input text that we provided. But it is bad in generating since it is an encoder based, and also it can read text from left as well as right. It can read the full sentence from left and the right. So this is also one characteristic of the BERT model. Now year come 2019. In 2019, OpenAI again came up with the GPT-2 model. GPT-2 model. So they till then they understood that pre-training is giving very good results. So why don't we scale? They introduced scaling with the help of GPT-2 model. In GPT-2, they scaled the same decoder based model. The architecture was same. The architecture was same. It was decoder only. They only increased the number of decoder layers. 48 layers was used to train GPT-2 model, and the objective was also same. Objective: predict next open. Predict next open. So both the things are same. Now scaling, if we can talk about scaling, the parameters are up to 1.5 billion. 1.5 billion weights and biases used to inside this model. You can now imagine how big the model was, and the data was taken from the website web text basically across the internet. The data they found on the internet, they used to train this model. They gave a very huge amount of data, and then GPT-2 came. Now let me tell you some shocking fact about GPT-2 model. Shocking fact. GPT-2 model, after training, GPT-2 model was doing something that no one expected at that time. That it was doing things that it was not explicitly trained on. So GPT-2 model was started doing machine translation, was started doing text summarization, was started giving code, when providing the prompt. So, so this model was not fine tuned. This is again another interview question, that why GPT-2 was not fine tuned, because OpenAI wants a single model that do everything, that do every task, that can be used for every task, and using fine tuning, it breaks the idea of one model for everything. So that is why they removed fine tuning completely, and they did the generative pre-training only. But this time the scaling was much bigger than the previous one. The data used to train this model was very huge as compared to GPT-1 model. And now the shocking facts are, the model was doing everything, almost everything. And this is called zero shot learning. This is called zero shot learning. Now let's move ahead. In the same year, Meta also enters into the large language world. Meta entry. And explicitly, Meta also was there in the training of GPT-2, or in the training of language models, because Meta built the PyTorch library in Python. So we mainly use PyTorch to train our deep learning models. But how did the Meta entry? So Meta basically, let me tell you one more thing about Meta, that Meta philosophy from the start was very clear. They believe in open source culture. They believe in openness, and also they emphasize the efficiency of the training of the model. Okay, so how did the Meta entry? So Meta trained the same BERT model. Meta trained the same BERT model and introduced a new model, RoBERTa. RoBERTa. They used the same model, but this time they gave more data as compared to the original BERT model. They feed more and more data, and this model was also again same encoder based model, but the performance was RoBERTa model was very good. So Meta proved that BERT was undertrained. BERT was undertrained. If we data is also very important as much as the architecture. So after that, let's move to the year 2020. In 2020, GPT OpenAI again come up with GPT-3. GPT-3. Now this time they extend the idea, the same idea, they use the same decoder only architecture, but this time they use 96 decoder layers, 96 decoder layer. So they almost double the decoder layers as they used in GPT-2. So they use 96 decoder layers, and the decoder architecture still the same that we know in transformer architecture, and the parameters they used, or we can say 175 billion parameters are present inside the GPT-3 model, and everything was same, objective was still the same, objective was still the same, predict next token, predict next token. Okay, so one more term I want to introduce, context length, and it was around 2035 tokens. So token is nothing but a piece of word. For example, predicting, predicting, predicting word. So predicting word, there may be one token or two token. How to token? We can also use predict plus ing. These are two separate tokens. So token is nothing but a word or piece of words. Okay. And context length, what is context length? It is the total length that we gave as an input to our model. Okay. So 2035 tokens of context length is provided for one pass, for one time, okay, to the model. So this is how GPT-3 was trained, and the training in training also only one stage: generative pre-training. They did the unsupervised learning. We can also say unsupervised learning. Unsupervised learning. In unsupervised learning, we don't have target value, but we have only input sentence, only input. We don't have output. So predicting next word is nothing but giving raw sentences, raw text that can be found on internet, on various websites, on various books, large number of books, data collected, and after that, this is how training was done for the GPT-3 model. And the GPT-3 model was was this much of huge that never seen at that time. And After this model, after this model, LLM era start. Before GPT-3, these models can be considered as language model. But when the GPT-3 came, and this is very huge, so people started saying large language model to these language models previously. So this is how large language world model word LLM word was first introduced in 2020 after GPT-3 came. Okay, so now let's move ahead. Now year came 2021. In this year, Google partnered with DeepMind. Now DeepMind is a company of Google. So they introduced a model, Gopher. And in this model, they the parameters was 275 billion parameters. And this is the first decoder based model introduced by Google. And here they used 80 decoder layers. 80 decoder layers. Okay. So after so with this model, Google wants to tell uh, AI world to tell the world that uh, we also are able to scale the language model as compared to GPT-3. So OpenAI was the first company who scaled the language model so much, and after that in 2021 Google also came up with this large model, and they showed the world that they can also train the GPT-3 level model. They can also do the scaling. So this model was really good in understanding and reasoning. So now in the next year 2022, Meta again come up with a new model, Opt. And what are the specialty of this opt model? Now, after 2021, almost all models are decoder based because generation they prefer the generation part most, and generation can be done better using decoder architecture. Now, in 2022, Meta came with this model opt, and the specialty of this model was to introduce openness. Again, the philosophy of Meta that they believe in open source culture. So they introduced this model, and the best part is also showed they also released the weights to the community, and experiments, ex- engineering, engineering, hardware, info, and cost to train these models. So Meta believes that these large language models should not be limited to the companies. They can be accessed by anyone. So that is why Meta first introduced this op model, and they release everything about this model. What are the weights used, what is the engineering, what are the hardware information, what are the cost, and everything. They released the full model, and they showed that that we also trained GPT-3 like models, and this is how we can do. And also, this is again a decoder based model, and 96 decoder layer used, and the parameters was around 158 billion. Now let's move to the next year in 2023. In 2023 was the year of Meta again introduced their famous model llama. And there are three variants of this model: 7 billion, 13 billion, and 65 billion. With this llama model, Meta proved that efficient training is also more important than the architecture. So, so the results for the 13 billion and GPT-3 model was same. And in GPT-3, how many parameter? 175 billion. So as you can see that 13 billion and 175 billion, there is very much bigger gap. Okay, but Meta proved that using less parameters, we but efficient training was more important to get the results. And we get the finally OpenAI introduced Chat GPT. ChatGPT in the same year 2023. Now, previously, all the models was large language model, but ChatGPT was the product of large language model. Product of large language models. Product of large language. It is not a large language model, but it is a product of large language model. And the good part of ChatGPT was simple UI. It is easy to use. And very shocking fact about ChatGPT was it took 1 month to reach 100 million users. This was the shocking fact about ChatGPT, and it became very much popular within 1 month. So this is the story of large language models, and in 2024 and 25 there are various new models came by different companies. And one more thing I want to add up in large language models, that finally two more companies are the backbone of large language models. First one is NVIDIA and the other is Microsoft. So NVIDIA provides GPU power. LLMs trained on GPU, no GPU, no LLM. No GPUs, no LLM. And finally, we have Microsoft. It provides the infrastructure. Infrastructure. It provides GPU clusters to the OpenAI, and GPT-3 and GPT-4 model was impossible to train without the help of Microsoft because they provide their Azure infrastructure and various computing power to the OpenAI, and this is how the GPT-4 and GPT-3 model was trained. So these two companies also plays an very important role because without NVIDIA there was no GPUs and no LLMs. So this is the whole story of large language models, and I hope you enjoy the story of large language models. And I'm wrapping up here. And if you like this video, then please do like, share, and subscribe to my YouTube channel. Take care. Bye. See you in my next video.